In this video, we will demonstrate a system for secure sensor data collection in the IoT domain, developed as a part of RERUM project trials. Specifically, we will present the integration of transport layer security in the communication between RERUM devices, as offered by the DTLS protocol. Our specific setup, shown here, consists of one RERUM device and a RERUM Gateway. Both devices are equipped with a Zolertia RE-Mote platform that hosts an ARM Cortex-M3 processor running at 32 MHz, along with a dual radio transceiver that can operate both in 2.4 GHz and sub-GHz band, and offers wireless connectivity to the RERUM devices based on the 6LoWPAN standard. On the first side, the RERUM device plays the role of a server exposing sensory data, in our case ambient temperature and humidity, as scope resources by using the secure transport layer of DTLS. In order to achieve this, the standard tinyDTLS implementation was suitably adapted and ported on Contiki operating system that runs on the device. On the second side, the RERUM Gateway is equipped with two radio interfaces, namely a 6LoWPAN wireless interface provided by the Zolertia RE-Mote platform in order to communicate with the sensor device, and the Ethernet interface of a Raspberry Pi 3 that enables communication with the RERUM middleware server through the Internet. Special software implemented in Java language enables the RERUM Gateway to perform sensor registration functions, translate HTTP requests received from RERUM middleware into COAP requests, communicate them over DTLS with a remote COAP server, and finally send the collected sensor measurements back to the middleware server. The COAP and DTLS functionality of the Gateway software is provided by appropriate adaptation of the well-known Eclipse Californium and Scandium implementations, respectively. Now we will present the steps involved in secure sensory data transmission provided by our system. For this reason, let's inspect closer the Gateway log file. As seen, the Gateway main process has already started and the RERUM device has successfully registered to the Gateway. Now the RERUM middleware sends to the Gateway an HTTP request for observing a resource through which the remote COAP server exposes ambient temperature values. The Gateway software firstly translates the HTTP request into a COAP observe request and establishes a fresh secure session with the server by initiating a DTLS handshake, through which the security parameters of the session are negotiated. Here, a ciphersuit using 128 bits AES in CCM mode with an 8-octet integrity check value is used with a pre-shared key exchange algorithm to establish the session master secret. In this DTLS mode, a decreased delay for the completion of the handshake is offered. After the session is established, the COAP request is encrypted and sent securely from the Gateway to the COAP server of the RERUM device. The latter starts to reply with encrypted ambient temperature values based on the currently selected notification time interval. These measurements, shown as JSON strings in the logs, are decrypted at the Gateway and are then forwarded to the RERUM middleware for further processing. Now the middleware server sends a new HTTP request for observing the ambient humidity resource exposed by the COAP server. The Gateway again translates the received HTTP request to a COAP request. However, since an active secure connection already exists between the two entities, the request is immediately encrypted and sent to the server without the need of a new handshake procedure. In the screencast, you can now observe the plaintext humidity values received in the form of a JSON string, along with the formally requested temperature values. Finally, the middleware server cancels both established observations by sending two appropriate HTTP requests. The Gateway, like before, translates them into observed register COAP requests, encrypts them, and sends them to the RERUM device that securely acknowledges their reception. Then, the DTLS session is closed by an appropriate close notify alert sent by the client. The communication sequence described before can be also observed in this Wireshark capture. In orange color, we can see the DTLS handshake flights performed to establish a secure session. Then the COP messages are exchanged normally, appearing as encrypted application data of the DTLS record layer, here shown in blue color. If we click on this tab, we can see the decrypted payload of the sensor device responses, for example here for ambient temperature and here for ambient humidity. Finally, the session is terminated through the close notify alert of the client and the corresponding response of the server, here shown in red color.